Welcome to Ajat Bioacademy. Today I will talk about actin, myosin, troponin, tropomyosin and their functions. Okay, so in normal condition, that means before activation or before contraction, how it will be like that, and after that what will happen, and the changing, how the changes occur, and how it will contribute for the contraction. Then I will draw. So firstly, I will try to draw a actin monomers. Their helical structure like that. And these are the actin monomers, and they are remaining like a double helical structure. Okay, so like that. So you can say these are the actin. Okay, so actin is not free like that in resting condition, not free like that. So how it will remain? So if you think in another point is this points of actin monomer is the myosin binding site. Okay, so in normal condition they are covered, they are just blocked by a specific chain, that is a specific chain actually that would be like that. Okay, so the active binding site, the binding site means active binding site with myosin. So in the black color you can say this is the active, that is binding site, myosin binding site. Okay, and what would be the name of the chain of the blue color? That is your tropomyosin. Okay, different anchoring some protein complex are there, they will just maintain the overall structure. So how? So in 7 monomer structural structural distance, one protein complex are there. 7 monomer, you can think 1, 2, 3, 4, 5, 6 like that. Suppose you can think here is one protein, here is another protein, and you can think this is the another one, that is okay. So in 7 monomer interval, again you can think here, you can think, and also like that. So this protein complex name is, actually the overall protein complex name is troponin. Okay, and the individual troponin name you can consider, this one is, you can consider this is troponin C. You can think this is troponin I, or you can think this one is troponin T. So in normal condition, that is it is not taking part in contraction. Troponin complex for every 7 monomer interval, and you can think this is almost 5.6 nanometer in distance. So how it will bind with the myosin, that will make contraction. So that is the point. So now I have to draw another things, that is that is myosin. Suppose you can think, because it is thick filament, already I discussed in my previous lecture, and this is thin actin. So here some binding head, actin head are there. So here like that, actin head, myosin head. So what will happen when they will take part in the contraction? Then the events will just going to start. How it will start, I will just try to explain now. So here the binding site, or you can say the myosin head, will bind with the actin, and actin, the binding site of actin with the myosin is already blocked by the tropomyosin. Okay, so no chance to bind with the myosin. So no contraction. So what will happen? Firstly, I will just try to explain, that is, if you think this is your cardiac muscle cell, and through this action potential, you can think this is the T-tubule, and here on calcium channel are there. You know the L-type calcium channel, L-type calcium channel. You can also say dihydropyridine receptor. Okay, when action potential will reach to the T-tube, and then the calcium channel will open, and some calcium are there within the T-tubule, and that will enter into the inside the cardiac cell. Then what will happen? Here, beside here, sarcoplasmic reticulum is there. So I will not go to the details because already in my previous video. So here channel, that is ryanodine channel. So RYR channel is also calcium channel. When the calcium will enter, suppose the red color calcium is here from the T-tubule, and it will just bind with the ryanodine receptor, and it will change its conformation. And the sarcoplasmic reticulum is a storekeeper of calcium. Okay, so this ryanodine receptor will open, channel will open, not receptor, and then calcium will come out from the sarcoplasmic reticulum. And what will happen? Intracellular calcium will be more. Okay, now the events is already starts. So that calcium will bind with the troponin C. Okay, so that troponin C, calcium will bind. Okay, and the conformational change will occur. And then what will happen? It will inhibit the troponin I, that is inhibitory troponin, that will inhibit the actin myosin binding in the absence of calcium. Okay, so when intracellular calcium will be higher, when it will bind with the troponin C, the conformation will change occur, and it will suppress the inhibitory function of the troponin I, and troponin T will just try to manage the tropomyosin from their binding site, or just it will try to remove from that site. Okay, that means try to rotate. Okay, so how calcium when bind with the troponin C, then the sequential events already started, and what will happen? It will try to just change the position of the tropomyosin, like that. It will change the tropomyosin position, and that will make free the active binding site of the actin. Okay, that means the actin binding site will be free, like that. And the binding site will be free. Okay. So the actin is ready to bind with the myosin. And how myosin head will bind with the actin? Here ATP is there, and due to its ATPase activity, the ATP will be hydrolyzed into ADP and one inorganic phosphate. So what will happen? The ADP will bind with the myosin head, just like that. Okay, and what will happen? It will change the conformation and it will turn towards the actin. How? It will use the energy which is produced by the hydrolysis of ATP. That means when ATP will be hydrolyzed and it will produce energy, and that energy will be used to just change the conformation. How? Directly ADP will bind with the myosin head. Okay, so then what will happen? It will just, from that structure, it will change like that. That means like that. That means it was like that, and it will be like that. That means position change. Then what will happen? It will bind with the actin binding site. Okay. So when it will just change towards the actin binding site, and it will change the structure like stretching towards itself. So this activity is called power stroke. Okay, it means powerful stretching towards the myosin towards by the myosin head, and when myosin head bind with the actin, when it will be able to bind with the myosin, when calcium will bind with the troponin C, and it will change the function of troponin I and troponin T. Troponin T actually it will maintain the conformation, and also when troponin C will be activated by the calcium, then it will play an important role by changing the activity of troponin I, and it will make the change of tropomyosin to just free the binding site of actin for the myosin. Okay, and during that time the ATP will just turn into ADP and that bind with the myosin head, and energy will produce, and that will use for the power stroke. Okay, the one contractile event is done. Then what will happen? Instantly new ATP will bind ATP, and then it will again will be in normal position like that by ATP. That means when ATP will be hydrolyzed into ADP, then it will contribute, and when ATP again will bind, then it will be again in normal position. Okay, so one has been done. So this is the overall troponin, tropomyosin, actin, and myosin activities. But here some another additional information is that troponin I, the inhibitory function, also be suppressed by PKA. You know, PKA is the signaling protein, that in protein kinase A, which is basically produced from the influence of the beta 1 receptor activation, okay, by your G protein couple receptor by ATP dependent protein kinase. Okay, that PKA can phosphorylate that L type, and also it can phosphorylate that channel, and it can increase the intracellular calcium for the contribution of contraction. Okay, but here related to troponin tropomyosin, PK can phosphorylate the troponin I. Okay, and its inhibitory function will be suppressed, and then what will happen? It will facilitate more calcium bind with the troponin C, and the event will be more quicker and more precise. Okay, more appropriate way. So the main theme is actin is wrapped up by its binding site by the tropomyosin, and it is just maintained by a complex protein, that is troponin, and troponin I, troponin T, and troponin C. Okay, so actin is not free to bind with the myosin. Okay, so when troponin C will be activated by the binding of calcium, the conformational change will occur, and it will contribute by the help of troponin T and the suppression of activity of troponin I. The tropomyosin will be just rotate from its position, and it will make the free of actin. Okay, and after the ATPase activity by the myosin, it will just bind with the actin. Okay, so ultimately free actin will bind with myosin, and it will make a actin myosin complex, and that is contraction. Okay, and when the event is done, so when ATP will bind again, then it will detach from the breeze. That means, actin myosin will make a breeze. Okay, suppose they were like that, in that way, and when they just pull the actin towards the M line of the sarcomere, if you just recall, or you can just rewatch my lecture, then that would be very useful for you. So that would be the contraction, and when the event is done, so then it will again relax. How it will again relax? So ATP will play an important role, and another one is that here on channel is there. So this channel name is, you can say, this is SERCA. This channel is basically responsible for reuptake of the calcium into the sarcoplasmic reticulum. Okay, so it will use ATP for its energy, and it will by active transport, it will just reuptake the calcium within the sarcoplasmic reticulum. So intracellular calcium will decrease. It will not play an important role for the changes of troponin C, and it will never take part in bind with the myosin, because actin will be not free. So here the SCRCA is responsible for reuptaking. Okay, but here another protein is there, inhibitory protein. You can say this is name is phospholamban, or you can say phospholipin. Okay, this protein is inhibitory protein, and that PK will just phosphorylate that phospholamban, that PK, and it will suppress its negative role. That means it will be more active to reuptake the calcium. So you can be confused. PK is basically responsible for contractile role. It will just phosphorylate to open the L-type channel, ryanodine channel. Then it will increase the contribution for contraction also by the phosphorylating of troponin I. But here the role is different, and this is only possible when your excessive calcium is there. Okay, it will try to prevent the excessive contraction, because always heart is contractile and relax in an optimum way. But when any unwanted occurrence or excessive calcium will increase, then that PK can change its role. That means PK has dual role. The main role is to contraction of the is to make the contraction of cardiac muscle by different ways, already I explained. But in a special case, it can make for increase the reuptake of calcium and decrease the calcium level, and finally for relaxation. Okay, so this is all about troponin, tropomyosin, actin, and myosin. So thank you very much.